Hello, in this video we're going to be proving lines parallel. To do that we're going to use converses of some particular theorems. This first one is saying that if angle 1 and angle 2, so these corresponding angles are congruent, we can say that these two lines have to be parallel, which is the converse of postulate 3-1. This table down here is the converses of theorems 3-7 to 3-10. And it's stating that if we get alternate exterior angles congruent, then the lines have got to be parallel. You could also say same side interior angles are supplementary. Theorem 3-13 says that our lines have to be parallel. So let's check it out. I want to show that particular lines on here are parallel, and I can see I've got these two angles marked, and they're made up of this line right here, as well as two other lines that are going in this direction. Now you can kind of see that a little bit with the colors, but you could also just rewrite that real quick over here. And these are the two angles that I am interested in. Now, these two angles are in the same spot. One's interior, one's exterior, interior, exterior. And they're on the same side of the transversal right here, but they're in corresponding parts. So we can say those two red lines are parallel thanks to that postulate we started with, 3-2, which is referring to the corresponding angles, are congruent. So that's telling us we've got two parallel lines. We've got this one, so TH. So we can say TH. This line has got to be parallel to this line over here, which is AM. So AM. Those lines have to be parallel thanks to postulate 3-2. Please make sure you redraw those diagrams. It makes it a lot easier to spot what's going on with the things. This is a bit of a mess. This is a lot more clear that I've got corresponding angles. In this next example, I redrew it a little bit just to make it a little bit more clear in the video. We've got these two angles and we want to try to get these two lines to be parallel. If we want these two lines to be parallel, these two angles, which are on the same side of my transversal and are on the outside of our two lines, those are same side exterior angles, they need to be supplementary in order for A and B to be parallel lines. This is theorem 3-14. So I just want to make sure that if I add those two together, they're 180 degrees. So 3x minus 2 plus 44 should equal 180 degrees. So I just need to solve that equation for x, and I'll know what x got to be so that they'll be parallel. So I got negative 2 plus 44, that's going to be 42. So, whoa, 3x plus 42 equals 180. Subtract that 42 from both sides. So we got 3x equals, let's see, that's 138. And then divide both sides by 3. So divide by 3, divide by 3. X equals 138 divided by 3, which is 46. So that's the value that is going to make those two angles supplementary. And if those two angles are supplementary as same side exterior, then A and B have to be parallel. So more examples down here. We've got 2 and 3 are supplementary. We want to see who's got to be parallel. So here's angle 2 and angle 3. I can tell they're on the same side of this line and in between these two lines. So they are same side interior. Between these lines and here. So we're looking at these two angles. Same side interior angles makes A and B parallel. A is parallel to B, and that is using, let's see, same side interior is theorem 3-14. 3-13, excuse me. This next example is saying that 1 and 4 are congruent. So here's angle 1 and here's angle 4. So that seems to be using those same lines that we had before, but now we're talking about those outside ones. So they're same side exterior angles. And so that's also going to make A parallel to B, this time using theorem 3-14. Now, this next one is using angle 7 and angle 11. Now, 7 is made up of L and B, and 11 is made up of A and, sorry, M and A. So if I kind of try to like make my diagram, like I end up like making the whole thing. Now, these are kind of in corresponding spots, but they're using too many lines. There's like 4 lines in this diagram. So even though it looks corresponding, we're not able to say that these two things have to be parallel. So this one is just not possible because there's just too many lines here. We should only have 3 lines like what we've got up here. When I make that kind of shortened diagram, I still end up with 4, which is too many to prove anything. All right, now these next few examples aren't as important. They're just kind of neat. It's this idea that if things are parallel to each other, then we get another parallel. If we get perpendiculars, then we're able to get more perpendiculars. There's sort of consequences of our same side interior, alternate interior nonsense stuff. But let's just kind of take a look at what we're able to do with these things. Think about them as sort of like a transitive property of parallel and perpendicular. So if we're looking at this example, we know A and B are perpendicular. So we could draw like A like this and B sort of perpendicular to that line. B has got to be parallel to C. So then we can make another line over here. Okay, that's C. And C's got to be parallel to D. I'm going to put D down here, but I want to make sure that C and D are parallel. Because of all those kind of consequences of like one thing into the another thing, I'm kind of forced to make D and A perpendicular. So we're able to conclude that A is perpendicular to D. That's sort of like what we're doing with these things, just trying to like cut out all of this middle stuff in the diagram and figure out like, okay, how are the ends matching up? So if we did this one, we've got A and B are parallel. So here we go, there's A, and then here we go, that's B. Okay. B and C are parallel. So I just need another line here that's got to be parallel to B. C and D are perpendicular. So C's right here. I need a perpendicular line. I'll call that one D. And then D and E also have to be perpendicular. So if I'm going to be perpendicular to this, maybe I'll put it down here, call that E. But based on all of these lines, I want to kind of cut out those middlemen. And what I end up with is another A, and this time it is parallel to E. Make these little diagrams, makes these problems really easy. A place you have seen this property but maybe didn't realize it is ladders. Ladders use this property. Rungs are parallel and the top rung is perpendicular to one side. So all of these rungs of our ladder are parallel and this top rung is perpendicular to one side. So we can say all rungs are perpendicular to the side. Because if these two are perpendicular, then all these ones have to be perpendicular if all these ones are parallel. So then this one is saying, oh, these sides are parallel and the rungs are perpendicular to one of our sides. Hey, guess what? The rungs have to be perpendicular to the other side. In this last one, we're not actually able to conclude everything. So each side is perpendicular to that top rung. So we kind of get something like this. But we don't know what the relationship is with the other rungs of this ladder. So this one is nothing new. Since we only get that one pair of right angles, we don't get anything else. Well, I suppose we could say that those two sides, oh, there is something. The sides are parallel. There's something. I was wrong. Since those two are perpendicular, then these sides have to be parallel. Okay, I guess there was something, so that's good. That's it for our video. Keep in mind when you're taking a look at these big diagrams with a lot of numbers, make these little quick diagrams that are demonstrating what angles you're working with. It makes it a lot easier to identify or be unable to identify what sort of angles that you're working with. And these are all the converses of the original statements that if they're parallel, then we get either they're the same or 180. Now, if they're the same or 180, we're able to show that lines are parallel. Thanks for watching. Bye bye.